Hey everyone, and welcome back to another lab. In this session, we will look into the fundamentals of VTP, that stands for VLAN Trunk Protocol, a protocol designed by Cisco to simplify VLAN management in network environments. In large network deployments, managing virtual local area networks or VLANs across numerous switches can be an overwhelming task. Manual configuration of VLANs on each switch is time consuming and prone to errors. Cisco VTP addresses these challenges by automating the distributions of VLAN configurations across the network. And the rule of VTP is that it operates at layer 2 of the OSI model and facilitates the distribution of VLAN configuration information between switches. By designating certain switches as VTP servers, VLAN information can be centrally managed and propagated to other switches in the network. There are three primary modes in VTP. These are the server mode, the client mode, and the transparent mode. So, the server mode, servers maintain the VLAN database and propagate updates to other switches in the same domain. Whereas the client mode, clients receive VLAN configuration update from VTP servers and synchronize their VLAN database accordingly. And finally, we have the transparent mode. And the transparent switches do not participate in VTP domain updates, but pass VTP messages transparently through the trunk links. I included the link for the playbook in the description below. And in this document, you will find very useful summary information related to VTP protocol and VTP versions as well. So regarding the lab objective of this lab is to configure VLAN trunk protocol between two distribution switches and three access switches. We will also implement dynamic trunking and switch virtual interface or SVIs. We will establish a VTP domain by configuring the distribution switches as VTP servers within the designated domain to ensure VLAN configuration consistency across the network. Trunk links will be configured with Dynamic Trunk Protocol or DTP to negotiate trunking capabilities and establish trunk connection between switches. VLAN propagation will be ensured by creating VLANs on the distribution switches, and we will verify their propagation to the access switches via VTP protocol. Finally, connectivity testing will validate inter-VLAN routing and communication across multiple departments. That confirms the successful implementation of VLANs using VTP protocol, and this prepares you for real world networking scenarios. Regarding the lab topology, as you can see on the screen, we have a full redundant network that consists of two layers. We have the distribution layer, which we can see D switch 1 and D switch 2. We also have the access layer, which consists of three switches. These are the A switch 1 or access switch 1, access switch 2, and access switch 3. We have a couple of VLANs that each represents a department. So the IT department resides in VLAN 10, and we have the HR department that resides in VLAN 20. All links are connected to the end hosts will be access links, and all links are connected to the distribution switches will be trunk links. We have D switch 1 and D switch 2 will operate in VTP server mode. And we have access switch 1 and access switch 2 will operate in VTP client mode, whereas access switch 3 will be operating in VTP transparent mode. So regarding the end host, we can see that PC1 and PC3 as well as PC5 are part of the IT department, and we can see PC2, PC4, and PC6 are part of the HR department. So regarding the lab tables, the first table that we see is the switch VLAN table. And this table presents details regarding the devices, the interface configurations, and associated VLANs. So we can see the device name. This column lists the name of the network devices in this lab. The interface ID is the column that displays the unique identifier of the interface on the respective device. And these are the interfaces that will be active during the lab. We can see the interface mode, and here it indicates the operational mode of each interface. It specifies whether the interface is configured as dynamic auto or dynamic desirable, meaning it dynamically negotiates trunking, or access, indicating it's set to access mode, where it only carries traffic for a single VLAN. And finally, we can see the VLANs ID column. And this column represents the VLANs that are associated with each interface. And it lists the VLAN IDs assigned to the respective interfaces, indicating the VLAN membership of each interface. If I scroll a little bit down, we can see the SVI table. So these are the SVI interfaces that will be created during the lab. For example, we can find the distribution switch 1 and distribution switch 2. Distribution switch 1 will have VLAN 10 or SVI 10 and SVI 20, and the same applies for distribution switch 2, and each SVI will have its own IPv4 address. Next, we can find the switch VTP table, and in this table, it lists all the devices in the lab, and it identifies the VTP mode. For instance, we have discussed earlier when I walked you through the lab topology, we did mention that access switch 1 and access switch 2 will operate in client mode, whereas access switch 3 will operate in transparent mode. And finally, the distribution switch 1 and distribution switch 2 will operate in server mode. Finally is the host IPv4 address table, and in here is pretty much straightforward. We have the device name, in that case PC1 all the way to PC6. We have the interface ID, which is the NIC card for each of these PCs. It's quite consistent across the table, is fast Ethernet 0. And the IPv4 address for each PC, for example, PC1 will have 192.168.10.10 with subnet mask 255.255.255.0, which is /24, and the default gateway is the SVI that will be configured on the distribution switch. So for instance, PC1 will have 192.168.10.3. So the first task that we are going to tackle for this lab is the trunk configuration. So on access switch 1 and access switch 2 and access switch 3, we will configure the interfaces that are connected to the distribution layer with these two tasks. So including the interface description, and the second task is to configure both interfaces to use dynamic trunking. And then once we've done that, we will verify our configuration and validate our config. And then after this, we will move to step B. And that step, we will be tackling distribution switch 1 and distribution switch 2. And on the links that are going back to the access layer switch, we will do these two tasks, which are setting the interface description, and we will also set the dynamic trunking to desirable option. So we are going to use the dynamic desirable command in this case. And then we will move into the second task, which is going to configure the interface that is connecting the distribution switch 1 and the distribution switch 2 back to back with these configurations. So we will set the interface description accordingly, and we will also configure both interfaces to use dynamic desirable. Once we've done that, we will do some validation and verification. And then once we are happy with our configuration, we then move to step number 2. So step number 2, we will execute the appropriate command to display the current status of the VTP on the distribution switch, and we will try to analyze the data and find out what is the current domain name that is configured. And we will try to also understand and learn the current version and what is the current VTP mode. We then move to step number 3, where we are going to execute the appropriate command to display VTP counters, and we go through the output, explain the output, etc., etc. And then we would need to also verify that each switch in the lab has a blank VTP domain name and set the VTP version to 2 if the current version is set to 1 on the distribution switch 2. We then move to step 5, where we will do some further configuration, which is going to configure VTP domain name with the IEE word. And then we will also verify that, which is step number 6. And then we're going to also check the current mode on each switch from the lab to make sure that the VTP protocol is actually working as expected. And we will verify this with the output from the other devices or the neighboring devices. And then we move to step number 8, where we are going to do some further configuration for each switch so that we can assign the appropriate VTP mode for each switch based on the table provided in the lab. And then we are going to perform some in-flight checks just to make sure that our configuration has been taken effect. And then we're going to move to step number 10. And step number 10, we will issue the appropriate command to display the current VLAN configuration on every switch. That will help us determine if VTP is operating or not. And then we tackle step number 12, where we will log into each switch and check the VLANs database. And we need to check if the database has been populated. And at this point, on access switch 1 and access switch 2, the VLAN database should be populated automatically. However, on access switch 3, the VLAN database should remain the same. And the reason being is because the switch will be configured in VTP transparent mode. We then move into step 13, where we will do some verification of the current VTP status, including the configuration revision. And then we're going to tackle step number 14, where we will go back to access switch 1 and try to remove VLAN 30 and 40. And we will see if we are able to do this or not. And we will also explain why, yes, or why not. And then we will move to step number 15, where we are going to do some SVI configuration. And on the distribution switch 1 and distribution switch 2, we will create an SVI for each VLAN, as mentioned in the table above. And we will verify the SVI configuration accordingly. We then move to step 16, where we are going to create VLANs 10 and 20 on the access switch 3, since it is operating in VTP transparent mode. And then we're going to move to step 17, where we will need to perform some access port configurations. So these are for the end hosts, or the links that are connected to our end hosts or our PCs. So on access switch 1 and access switch 2, as well as access switch 3, we will assign the gig Ethernet 101 and the gig Ethernet 102 interfaces with the appropriate VLAN access. And we will include the description as well as forcing the port to operate in access mode. We will also do some in-flight checks to make sure that our configuration is accurate and as expected. We then move to step number 18, but this step has already been done prior to the lab. However, if you are building this lab from scratch, or you're building the lab physically yourself, then you would need to perform the step number 18, where you are going to push some configuration to the end host, where you're going to assign the IPv4 address, the subnet mask, and the default gateway. Next is step number 19. So on D switch 1 and D switch 2, we will enable IP routing so that we enable the inter-VLAN communication between different departments. And then we move to step 20, where we will do some connectivity testing. We're going to ping from PC1 to PC3, PC2 to PC4, PC1 to PC2, and PC3 to PC5. And then if the ping is successful, we can go ahead and save the configuration. However, if the ping is not successful, we can then follow these steps to help us troubleshoot the issue, isolate the problem, and try to fix it here and there. Okay, so this is the moment where I ask you to pause the video and give this a go yourself if you want to test your knowledge and skills. So in the video description, I included the lab document so that you can go ahead and download it and practice at your own pace. And also I included two packet tracer labs. The first one is the pre-configuration, which is for those who want the lab ready to go through the lab challenges. And the other packet tracer file is the post configuration, which is for those who want to have the full solution to compare their solution with mine. So the first task that I'm going to tackle is the trunk configuration task. So on access switch 1 and access switch 2 and access switch 3, we will do some configuration on the interfaces that are facing the distribution switches. So I'm going to start with access switch 1. So I would say interface range gig Ethernet 1/1/1-2. And here I'm going to say switch port mode dynamic auto. And also I'm going to set the description to link to distribution switch. Let's do the same thing on access switch 2. Oops, I forgot to actually include the description, so I'm going to go back to global config mode and go back to the interface range gig Ethernet 1/1/1-2. And I'll set the description to link to distribution switch. And let's do the same thing on access switch 3. So this time I'm going to say interface range gig Ethernet 1/1/3-4. And I'm going to do the same thing, switch port mode dynamic auto. And finally, the description, I'm going to set it to link to distribution switch. So let's go back to access switch 1 and perform some in-flight checks. So the first one that I'm going to do is the show interface gig Ethernet 1/1/1, and I'm going to include the word switch port. And what I wanted to point out to you guys is that the current administrative mode is set to dynamic auto, which confirms our configuration. And also, if I did say show interface status, you can see that gig Ethernet 1/1/1 and /2 are configured with the appropriate description. And finally, if I say show run, you can see this is the current configuration for these two interfaces. So next, under the first task, we're gonna tackle the subtask number 2, which is on the distribution switch 1 and switch 2. We will need to do some trunking configuration. So I'm gonna go back to the distribution switch 1, and I will go to config mode, and from here I would say interface range gig ethernet 1/1/1, and I'm going to include dash, and I will set 3 to include the 3 interfaces so we can configure them simultaneously. And in here I would say description link to access switch, and then I'm going to set the switch port mode to dynamic desirable. Let's do the same thing on the distribution switch 2. I would say interface range gig ethernet 1/1/1-2. I also want gig ethernet interface gig ethernet 1/1/4. And in here I'm going to set the description first, link to access switch, and then we're going to say switch port mode dynamic desirable. Next, we can tackle the interface that interconnects distribution switch 1 and distribution switch 2, which is the gig ethernet 1/0/1. So I would say interface gig ethernet 1/0/1, and I'm going to set the description first. And I'll say link to the switch 1. And I'm going to say I'm going to set the switch port mode dynamic to desirable. And I'm going to do the same thing on the distribution switch 1. So I would say interface gig ethernet 1/0/1. Set the description first, link to d/switch 2. And then let's configure the dynamic desirable option. So now let's do some in-flight checks. So I'm going to say show interface trunk. So what we see on the output here is the port ID gig ethernet 101, and you can see the current mode is desirable, which what we have configured statically on that interface. And you can see that the current encapsulation, it is .1q, and it is being negotiated as well because we haven't actually hard coded it. The current status is trunking, and the current native VLAN is set to 1. And the same applies for gig ethernet 1/1/1, as well as gig ethernet 1/1/2 and gig ethernet 1/1/3. And all these links are connected back to our access switches. The current VLANs that are allowed via these trunks are VLAN 1 all the way to 1005. However, the current VLANs that are allowed and inactive is only one VLAN, which is VLAN 1. So let's do the same thing on the distribution switch 2. And you can see we get similar output as well. Next, let's perform another command, which is the show interface status. And on switch 2, or the distribution switch 2, we can see that we have configured 3 interfaces that are going back to the access switches. These are the gig Ethernet 1/1/1, as well as /2, as well as /4. And we also can see that gig Ethernet 101 is the link that is going back to the distribution switch 1 and currently is operating in trunk, etc., etc. One final in-flight check command that you can do is the show running slash our dash config, and we're going to include the pipe, and we're going to also include the section, and we're going to say 1/1/1, and we're going to include the dollar to stop at this point. And you can see here, this is the current configuration for this interface, gig Ethernet 1/1/1. Next, let's move to step number 2, where we would need to look back to the distribution switch 1. And in here, we will need to execute the appropriate command to display the current status of the VTP on the distribution switch 1. So we're going to say show VTP status. And this command displays the current VLAN Trunking Protocol configuration and status on the Cisco switch. And it provides information about the VTP domain, the VTP operation mode, the VTP version, and the configuration revision number, the maximum VLAN supported, and the existing VLANs. So, for instance, what we can see here that the current VTP domain name is set to null or empty, as you can see on the screen. The current VTP version that is running right now is version 1. And the current VTP operation or operating mode is in server. And right now, maximum number of VLANs that can support locally is 1005. And as we speak, the current configuration revision is set to 0, which means nothing have been altered, nothing have been changed under the VTP configuration. And that means that there are no configurations have been made prior to this lab. And once we have started configuring the VTP domain, this is when we see the configuration revision will change and will increase every time we perform some VLAN or VTP configuration changes. So next, let's move to step number 3, and we will execute the appropriate command to display the VTP counters. So we're going to say show VTP counters. And this command provides information about the number of VTP messages sent and received by the switch, as well as details about the VTP pruning operation. And that's only if it is enabled. So, for example, we can see the summary advertisement received and the summary advertisement transmitted. Both of them are set to 0 because we haven't used it yet. But these numbers indicate the number of VTP summary advertisements received and transmitted by the switch. And these are used to propagate VLAN configuration information. We can see the subset advertisement received as well as transmitted. And these advertisements contain information about a subnet of VLANs within the VTP domain. Whereas the request advertisement received and transmitted, these are used to request VLAN configuration information from other switches in the domain. Whereas the number of config revision errors, that indicates the number of errors related to configuration revisions, such as inconsistency between switch configurations, etc., etc. And we also can see number of config digest errors, and this specifies the number of errors related to configuration digests, which are used to verify the integrity of VTP messages. And finally, we can see the number of version 1 summary errors, and that just displays the number of errors related to VTP version 1 summary advertisements if there are any. Let's move to step number 4, where we will verify that each switch in the lab has a blank VTP domain name and set the VTP version to 2 if the current one is set to 1, and we have just proved that the current version is set to 1, so we would need to do that. So I'm going to start with the distribution switch one. So I'm going to say show VTP status, and you can see that there is no domain name that have been configured. Let's do the same thing on the distribution switch too. Again, we have similar result. The same applies on the access switch one. The same for access switch 2. And finally, access switch 3 has no domain name being configured as well. So we're going to go back to the distribution switch 2 to change the version from 1 to 2. So we're going to go to the global config, and from here we're going to say VTP version 2. Gonna hit end, and then let's perform some in-flight checks. So we're gonna say VTP status. You can see that the current version right now is set to 2. Let's then verify that on distribution switch 1. So that has not been propagated, and the reason why it hasn't been propagated is because we haven't configured the VTP domain name. So let's move to step number 5. And step number 5, we will need to configure the VTP domain name with the IEE domain name. So we're going to have to do this. So we are going to go to the global config. And from here, we're going to say VTP domain name or domain, and then we're going to set the name. So I'm going to hit end, and I'm going to say show VTP status. And right now you can see that the current version is still 1. The VTP domain name is changed to IEE. Let's check what's going on with the distribution switch 2. Okay, so what we will need to do, guys, we will need to go back to config terminal, and then we are going to enforce VTP version 2. So we're going to say VTP version 2. And let's just repeat the same step. So we're going to say show VTP status. And you can see that the current VTP version is 2. Let's double check the distribution switch 1 for this. You can see that previously it was set to 1. Let's verify that now. And you can see that the current VTP version has changed from 1 to 2. Let's do the same thing on access switch 1. And this time you can see that this has been updated. We have the VTP version running is 2, and the current domain name is set to IEE. Let's carry on with the in-flight checks on switch 2. Again, you can see the current version is changed from 1 to 2, and the current VTP domain name is set to IEE. Finally, the last access switch. So we're going to say show VTP status. And in here we get similar output. So this covers step number 6. And now we can move to step number 7, where we need to check the current mode on each switch, and we can confirm that each switch currently is operating in server mode, and that need to be changed. So we will tackle step number 8, where we are going to configure access switch 1 and access switch 2 with VTP mode client, whereas access switch 3, that is going to be transparent. So we can start with access switch 3 since we are on it. So I'm going to go back to global config, and from here I will say VTP mode transparent. And you can see that the VTP setting has been set to transparent mode. We can do some in-flight checks instantly. So we will say show VTP status. And you can see that the current operating mode is changed from server to transparent. Let's do the same thing on both access switches 1 and 2. So I'll go to config terminal and I'll say VTP mode client. Let's say show VTP status. And here we can confirm that the current VTP operating mode is set to client. Let's do the same thing on the access switch 2. And again, the in-flight checks proves that the current operating for VTP is client. So that covers step number 9 as well. So let's move to step number 10, where we will need to check the current VLAN database on each switch. So we're going to do that quickly. Let's start with the distribution switches. Now we're going to say show VLAN brief. You can see that I haven't created any of the VLANs. These VLANs are the default VLANs. And I think what we're going to do next is we are going to create those VLANs in question. But let's just verify that our VLAN database is clean and it hasn't been altered. Same output on the distribution switch 2. The same applies on access switch 1. And access switch 2. And finally, access switch 3. Good. So let's move into step 11, where we're going to jump back to distribution switch 1. And then from here, we're going to go to global config, and we're going to say VLAN 10, name, we're going to say IT department. We're also going to create VLAN 20. We're going to call this the HR department. And we're also going to create a couple of VLANs that will be tested across the lab and for a particular use case that I'm going to show you. But let's just go with the flow and follow the steps. So I would say VLAN 30 as well as VLAN 40. I'm going to end and I'm going to perform in-flight checks. So I'm going to say show VLAN brief. And we can see that we have created 4 VLANs. VLAN 10, 20, 30, and 40. Let's move to step number 12, where we're going to perform some in-flight checks across the rest of the devices, across the topology or across the network. So I'm going to go to distribution switch 2. And I'm going to up arrow to issue the same command. And you can see that the VLANs have been propagated automatically. So we have VLAN 10, VLAN 20, 30, and 40. Let's do the same thing on access switch 1. And again, we get similar output. Let's do that on access switch 2. And we also get similar result. Finally, we're going to do that on the access switch 3. And we haven't updated our VLAN database. That is because our current mode for our VTP is transparent. So at this point, let's move to step 13, where we will need to check the current VTP status. So I will go back to the distribution switch 1, and I would say show VTP status. And you can see that the current configuration revision is 8. And that number would be consistent across the network. So if I go back to distribution switch 2 and do the same thing, so show VLAN status, show VTP status, you can see that the configuration revision number is 8. So any modification that is going to occur across the distribution switch 1 or the distribution switch 2, this revision number is going to increment. So let's move to step 14, where we are going to try and remove VLAN 30 and 40 that has been propagated from the distribution switch 1. Let's see what is going to happen. So I'll go back to global config, and from here I would say no VLAN 30. And as showing, we couldn't remove VLAN 30, or if I tried to even remove VLAN 40, we wouldn't be able to do that. And this is simply because the access switch 1 is operating in VTP client mode. So if we try to remove these VLANs from any of the distribution switches, since they are operating in server mode, we will be able to remove those VLANs. So let's try that. So I'll go to distribution switch 2. Bear in mind that we have created these VLANs from the distribution switch 1, and now we're going to remove those VLANs from the distribution switch 2, which also operates in server mode, as you can see here. So we're going to go back to global config, and here I'm going to say no VLAN 30, no VLAN 40. And at this point, if I go back to user privilege mode and say show VTP status, you can see that the current configuration revision number has incremented to 10. And if I say show VLAN brief, you can see that I have deleted or removed those two VLANs, which are 30 and 40. And let's see if this changes have been impacted or has been taken effect across the other switches. So we go to distribution switch 1, and let's up arrow that. We can see that the configuration revision number is 10, similar to what we saw on the distribution switch 2. And let's say show VLAN brief, and you can see that both VLANs 30 and 40 have been deleted from the VLAN database. So let's go to our client or our access switches, which are operating in client mode, and let's say show VLAN brief. And you can see that VLAN 30 and VLAN 40 are no longer exist. And let's do that one last time on access switch 2. You can see that they were here, but in this instant, they have gone. So if I say show VTP status, you can see that the current revision number is 10. Next, let's move into step number 15. And here we are going to do some SVI configuration. So I'm going to go back to the distribution switches, and I'm going to start with the D switch 1 or distribution switch 1. And I'm going to go to global config again, and I would say interface VLAN 10, IP address 192.168.10.3, and the subnet mask is 255.255.255.0. And I'm going to up arrow multiple times to get the same command, and then change the 10 to 20. Do the same thing with the IP address. Change the 192.168.20.3, and then hit enter. And that is done on the distribution switch 1. Let's just do quick verification. So I'm going to say show IP interface brief. And you can see these two SVIs have been created successfully. Now let's move into the distribution switch 2. Let's perform some in-flight checks. So I'm going to say show IP interface brief, and we're also going to include only the SVIs. So you can see that these two SVIs have been created successfully and according to our lab requirements. The next step is to create VLAN 10 and 20 on the access switch 3, since it's operating in VTP transparent mode. So we would need to perform that manually. So I'm going to go back to that switch, and I'll go to global config. And from here, I would say VLAN 10. I'm going to name that VLAN. I'm going to call it IT department. Do the same thing for VLAN 20. And I'm going to call this HR department. Now that we've created our VLANs across the network, we can then move to step number 17, where we are going to configure some access port configuration. So on access switch 1, access switch 2, and access switch 3, we would need to tackle the interfaces that are going back to the end hosts to enforce the switch port to operate in access mode. We are also going to set the appropriate VLAN for each interface, and we're going to include the description for each interface. Since we are on the access switch 3, we can start with this switch. So I'm going to go to global config again. And I would say interface gig Ethernet 1/0/1. Description, link to end host. And I'm going to say switch port mode access, switch port access VLAN 10. Let's do the same thing for interface gig Ethernet 1/0/2. And this switch is pretty much done. So I'm going to just do some in-flight checks. So I'm going to say show VLAN brief. And you can see that these two interfaces are configured with the appropriate VLANs and appropriate department. Let's log into access switch 1. Do the same thing. I'm going to say interface gig Ethernet 1/0/1. Going to say description, link to end host, switch port mode access, switch port access VLAN 10. Let's do the in-flight checks. And you can see both interfaces have been configured successfully. Let's move to the last access switch. Go to global config. And then from there we say interface gig ethernet 1/0/1. Let's set the description. Link to end host. Switch port mode access. Switch port access. VLAN 10. Now this is done. Let's just do some in-flight checks. And we can see that both interfaces have been configured with the appropriate department or appropriate VLANs. Next is the step where we need to configure the end host configuration. As I mentioned earlier, this step has already been done prior to this lab or this session. And what I will do, I'll just show you a couple of PCs just to make sure that you on the same page and following along. So if you just like click on any of the PCs and you go to IP configuration, you can see the configuration has already been populated. If I go back, you can go to command prompt, and from there you can issue the IP config. And from here, you'll be able to see the IPv4 address details. So next, we will need to go back to our distribution switch 1 and 2 and enable IP routing. So I'm going to do that now. So I'm going to say IP routing, and then I will exit. Do the same thing on the distribution access switch 2. That will help us enable inter-VLAN between different departments. And at this point, we can then move to step 20, where we need to do some connectivity tests. So the first test is we are going to ping from PC1 to PC3. So they're going to be in the same department, the same VLAN, but they are located in different switches, or they are connected to different switches. So I'm going to go to PC1 and I will set it there, and I'll get PC3. Go to desktop and let's just get them side by side. So we say ping from PC1 to PC3. So let's just reveal the IPv4 information on PC3, and let's say ping 192.168.10.11. And we can see that we have reachability and accessibility between PC1 and PC3. So that test is passed. Let's do the same thing for PC2 and PC4 as well. And let's just put them side by side. So from PC2, let's ping PC4. So we're going to say ping 192.168.20.11. And again, we have reachability. Next, let's ping from PC1 to PC2. So this will involve inter-VLAN between different departments. So we're going to say PC1 and PC2. So I'm going to say ping 192.168.20.10. And you can see that we have successful ping. If I repeat the test again, we get 100% this time. Okay, so our final test is we're going to initiate a ping from PC3 to PC5. So let's do that. So that's PC3 and that's PC5. Let's just put them side by side. So I'm going to say ping 192.168.10.12, and we have successful connectivity as well. So at this point, we can move to step number 21, where we can go ahead and save the configuration. And it's easy to do this. So you just need to go back to the CLI, and you've got two options. You either say write mem, or you can say copy running -config space startup. And that way you have saved your configuration, and you need to do that across your topology. Okay, so that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn on notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.